Okay, so in this video, we talk all about the integration by parts. So which is the formula, the integral of UDB is equals to UV minus the integral of VDU. So always remember that in integration by parts, so dx is always included in the B, no? Okay, so that is the first. And then the second is it must be possible to integrate dv directly, no? Then it is best usually to choose the most complicated factor as dv, no? Okay, so in integration by parts, so ano siya, application, which is the integrants involving products of different function, no? And then involving logarithms, then also the inverse trigonometric functions, no? So those are the uh, application of integration by parts. And then consider this example number one, which is the integral of ln quantity of x squared plus e squared dx. So let's say let u that is equals to the ln x squared plus e squared, and then dv that is equivalent to dx. Okay, and then we derive u, okay, the equivalent of u, so which is du, and then the derivative of ln quantity of x squared plus e squared. So take note that we apply here a chain rule of process of n solving in this case. Then we have the x squared. Okay, so the derivative of x squared plus e squared, that is 2x. Take note that e squared is a constant. And the derivative of ln quantity of x squared plus e squared, so that is 1 over x squared plus e squared. So we can rewrite 2x dx over x squared plus e squared. To obtain the equivalent of v, so we must integrate dv and also dx. So the integral of dv, that is v, and then the integral of dx, that is x. So we have u here that is equivalent of ln x squared plus e squared, then multiply by x, then minus, so the integral of where v is x, and then du is 2x over x squared plus e squared. Okay, then dx. Next, this is x ln x squared plus e squared, okay, minus, so we have to multiply x here. So we write 2 integral of x squared over x squared plus e squared, then dx here. Okay, and then we, to obtain the x squared, so we use the long division theorem, is x ln quantity of x squared plus e squared minus 2, okay, the integral of, so when you divide x squared, okay, something like that, and x squared plus e squared, okay, so we have 1 here, then x squared plus e squared, okay, so we change, this is a positive, we change negative here, and then also this is minus, so we can now cancel x squared, okay, so the remaining is, that is negative e squared, so therefore the remainder is negative e squared over x squared plus e squared, so and that is minus e squared over x squared plus e squared, okay, so we can now write here minus e squared over x squared plus e squared, so we can write also the quantity dx here, okay, so we distribute dx, okay, so therefore this is x ln x squared plus e squared, minus to the integral of 1 dx, okay, and then so we can also take a bracket here, then minus the integral of e squared over, so take note that e squared is a constant, so you can also rewrite like this, no, integral of dx over x squared plus e squared, okay, then we have the bracket, the next, that is x ln x squared plus e squared, so the integral of 1 dx, and then we multiply times 2 or negative 2, which is negative 2x, and then next is we have positive here, negative times negative, that is positive, 2e squared, okay. So we can now integrate the integral of dx, x squared plus e squared, no, okay, so to integrate that we use this formula, no, and the inverse trigonometric function, integral of du over u squared plus e squared, okay, so that is equivalent of 1 over e arctan or tan inverse, that is x over e, then plus c, okay, so that is the equivalent integral of that, okay, or this is, sorry, this is u, okay, this is 1 over e, then arctan, that is x over e, then plus c, okay, so we finalize the answer, So that is equivalent of x ln x squared plus e squared, then minus 2x, then this is e squared. We can reduce or simplify, so that is 2e, then arctan x over e, then plus c. So that is the final answer.